In this video, we are going to go over how to factor with a method called completing the square. In order to complete the square, what we are trying to do is form what is called a perfect square trinomial. The definition of that is a perfect square trinomial is a quadratic, which is the result of squaring binomials. So for an example, what we have right there on the screen, we have the binomial x plus 3 squared, which is x plus 3 times x plus 3, which if we multiplied that out, that would yield the trinomial x squared plus 6x plus 9. That trinomial is considered a perfect square trinomial because it resulted from squaring this binomial right there. Now that we know what a perfect square trinomial is, we can look into how can we factor by completing the square. We can form one of those perfect square trinomials anytime we have an x squared plus a bx. We are missing the third piece to make that trinomial. We would get that third piece if we use our formula here by adding the b divided by 2 all being squared. This technique is going to allow us to solve more quadratics than we have been able to solve up to this point. The question that normally is asked is why b divided by 2 squared? Where is that coming from? So let's take a look at this visually so that we can figure out where does this b divided by 2 being squared come from. So if we start with that x squared plus bx, we can represent that visually using squares. So the x squared can be represented by the square that is x by x. That bx can be represented by the triangle, or not triangle, sorry, the rectangle that is b by x. So visually we can put x squared plus bx together as this picture here. This is x by x, and we have this b by x. What we're going to do is we are going to split this rectangle in half and move one of those pieces up top. So we're now looking at, here's my square that is x by x. Yes, I know that's not actually a square, that looks more like a rectangle. Just assume it's drawn to scale. And we now have half of this guy, which was a b divided by 2, and we moved the other half up here. So that's a b divided by 2. What are we missing? We are missing the little square that would go right there to complete this perfect square. What are the dimensions of that little square? B divided by 2 by b divided by 2. So the missing piece, the dimensions of that missing piece, would be b divided by 2 squared. So that's where it comes from. So now we're looking at the completed square that looks like this. We've added that little piece in there. This is x, and this was b divided by 2. So we can represent this as x plus b divided by 2 times x plus b divided by 2, which is actually the x plus b divided by 2 being squared. So this is where that b divided by 2 comes from. Let's look at an example to further explain this. In this example, we are asked to complete the square, and what we have is an x squared plus 10x. So let's look at this visually. We have an x squared, so we can draw that with the square that's x by x. And we have a 10x, so we can draw that with the rectangle that is 10 by x. Split that rectangle in half and move one piece up top. So each of those, if we split 10, would be 5 and 5. Now we are missing a little square that needs to go in there that happens to be 5 by 5. So 5 by 5 would be 5 squared, which is 25. So the missing piece would be 25. How do we go ahead and factor it out? Well, we can now write this as an x plus 5 times an x plus 5, which gives us the perfect square of x plus 5 being squared. So that would be our factored answer. As we move further along, we're going to be able to solve using this method now that we have something being squared. I'm sure some of you are already asking, do we have to draw this picture every time? The answer to that is really a yes and a no. If the pictures help you figure this out, by all means continue to draw it. If you find the pictures to be unnecessary and you can do it algebraically, then just do it algebraically. So let's look at one without drawing the picture. Here we have an x squared minus 22x. So what are we doing? We're looking at the b term. So my b is negative 22. We need to take that and divide by 2. So b divided by 2 is negative 22 divided by 2, which gives us negative 11. And then we needed to square it. So we're taking the b, dividing by 2, and squaring it, which gives us the negative 11 squared, which is 121. So if we were trying to complete the square, x squared minus 22x, the missing piece that we would need to add is 121. This now factors to a square of a binomial because this is a perfect square trinomial. If you don't recognize that, you can go through the long way of factoring. What are my factors of 121 that add together to give me negative 22? And that would be the negative 11. So x minus 11 and x minus 11 gives us the x minus 11 squared for our factored answer. So you can see we don't have to draw the picture, but if the picture helps you, please by all means continue to draw the picture. Let's look at another example. Again, I'm going to skip the picture and just do this algebraically. So what is my b value? In x squared minus 26x, my b value is negative 26. So I'm going to take negative 26 and divide by 2, and then I'm going to square it. Negative 26 divided by 2 gives me negative 13, and negative 13 squared gives me 169. So if we are trying to factor the x squared minus 26x, our missing piece, the value that would complete the square is 169. So this now factors to an x minus 13 and an x minus 13, which we would write as an x minus 13 squared. Let's look at one more example. In this last example, we have x squared plus 17x. What is different about this from the previous examples? If you notice, our b value here is no longer evenly divisible by 2 because it is not an even number. But that is not going to change our process any. We still follow the same steps. What is my b value? My b value happens to be 17. We are going to still divide that by 2 and square it. So 17 divided by 2 gives me 8.5, and 8.5 squared gives me 72.25. So if we were to factor this, the missing piece that we needed on an x squared plus 17x to make it a perfect square trinomial is that 72.25. We can now factor into an x plus 8.5 and an x plus 8.5, which we would simplify one step further to make it a squared. So x plus 8.5 being squared would be our final answer. Hopefully this video helped explain the process of completing the square, and you can now identify the missing value needed to make it a perfect square trinomial and use that value to go ahead and factor this into a perfect square.